All right, hi boys and girls. Today we are going to do piecewise functions day 2. I'm hoping that you did your homework from last night, you were able to check over those answers, and that you emailed me if you have any questions because it is going to get a little bit more challenging. I definitely encourage you to ask each other questions as well as look at the answer key and email me. This is kind of a hard topic, so I get it if you're a little bit confused or more confused than you normally are. But yeah, you definitely have to spend time on this topic. It's not an easy one. So let's go ahead and says discuss the following situation with your partner. You don't have a partner, so think about it. Then answer the questions below. A doctor's fee is based on the length of time. A sign found in the doctor's office reads, and then the 3. So up to and including 6 minutes costs $50. Over 6 minutes to no more than 15 minutes cost $80. And then over 15 minutes costs $80 plus $5 per minute above 15 minutes. So I would pause the video, take a second right now, and see if you can kind of answer these questions. Okay, if you were there for 12 minutes, what would the fee be? I'd love to call on you guys to tell me what you got, but we're not next to each other, so I can't do that. So the fee would be $80. And that's because it's between the 6 minutes and 15 minutes, and that means it's going to cost 80. If you were there for 20 minutes, what would the fee be? Well, that's going to cost $105. And that's because it's $80 plus $5 every minute above 15. It's 5 minutes above 15, so it's the 80 plus 5 times 5. And then if you were there for 4 minutes, what would the fee be? And that's $50. And that goes with the first kind of sentence here, up to and including 6 minutes. So you're kind of getting that thought today. Maybe we're going to take piecewise and we're going to turn it into real world situations. So for question number 2, I'd like you to go ahead and do it. Because we did this yesterday or in the video before, you should hopefully be able to get this down. So pause the video, try number 2, and then I'll put the answer up in just a second. Okay, take a look here. Here's what it should look like. One thing to remember from yesterday is if you have an open circle and a closed circle, it just becomes a closed circle. You know, hopefully that for the first function where x is less than 1, the arrow is going to be this way, and then greater than 1, the arrow's down here. Yeah, hopefully that was okay. We're going to move on. Oh, okay. All right, now it starts to get into what I would say is like a little more confusing because we're going to be working with a lot of decimals and fractions. We are going to skip just number 3 because it actually fits with something a little bit later in the unit. So we're going to go right ahead on to question number 4. And question number 4 is really us just going back to the do now question. So we're going to go ahead and graph this. Now we have 3 pieces. We have this first piece, the second piece, and then this third piece here. So what we want to realize is, is we're going to kind of make a table for each function, and we're going to use the domain like we have been. So we'll go ahead with the first one. So this is our really just y equals 50 function, and it's any value where x is less than or equal to 6. So I'm going to start with 6, and then I'm going to go less than or equal. So 5, 4, 3. I don't have to keep going, but I do know that there's an arrow there. And this is actually our easiest one because we know every y value is just going to be 50. And here's your x and y. So that's your first function. Your second function is 80, and it's also extremely similar. So we have x and we have y, and now we're going to be between 6 and 15. So 6, 7, 8. I'm really going to skip because I feel like I don't have to write down every single number knowing that it's all going to be at 80. So I'll just do like 6, 8, 10, 12, 14, and then I'll throw 15 in there because that's the ending number. You always want to include those two. So even if it doesn't really work with the table, might as well throw it in there. Okay, of course, I just accidentally deleted everything that we just wrote. So either, scroll back or, just keep what you have written down. And I'm going to do the last piece over here. Sorry about that. So we have the function 80 plus 5 times x minus 15. Now keep whatever you have on your paper. I'm sure it's fine. I just accidentally pressed erase, and I'm not going to rewrite it because you guys already have it. So I'll go ahead and start with that table. I would definitely put this into your y equals screen so you don't have to figure anything out by hand. But we want all the values just greater than 15. Now, even though it says greater than 15, we are going to include the 15, and we're just going to put an open circle there when we get to that point. So greater than 15 would be like 16, 17, 18. If those aren't great points in the table, then you can keep going. I'm going to stop at 18. I think that's enough. And then if you're looking at your calculator, hopefully you're seeing 80, 85, 90, 95. Now, for this function, we have an open circle here, and then we're going to have an arrow at the bottom. Okay. Now, if we look at all of like the y values that we're going to have, we notice that we have the 95, but that it's going to keep increasing. So we definitely don't want any less than, I would say, like 95 as our like y's. And then we also, let me see if I can zoom out a little bit. We also want to count by something either like tens or fives. So go ahead and see if you could figure out what we should count by. Okay, so I'm thinking for the y's, we should probably count by either fives or tens. So what I think I'm going to do is I'm going to count by fives, but I'm going to skip every other line just because I'm a little bit lazy, and honestly, this pen is super thick. So I'm going to say this is 10, 20, 30. You can go ahead and finish your y-axis. Okay, so your y-axis should be fully labeled, and then we just have to label our x-axis. And then looking, you want to have, I guess, somewhere between 0 and at least 15. So maybe we want to go at least up to 20. And so you can go ahead and figure that out. And again, I think I'm just going to count by ones, but also, I'll count by like halves. So I'll skip every other box and I'll do ones. So it'll look like this. I don't think this is going to work. Nope. Okay, so we're not going to count every other box. We're going to have to do each box. So go ahead and do each box as one. Okay, now that we're ready to graph, we can start with our first function that we were using, which was 50 when x is less than or equal to 6. Now, if you look at your table, you know that at the point 650, it's a closed circle. So that could be our first point, 6, 50. So that's going to go right about here. And then at 550, 450, and then it keeps going. But we also hopefully see that we are going left, and we're not going to put an arrow going this way because that makes it seem like we're going into negative x values. So instead, what we want to do, this is a real world problem, so we want to think of it realistically. We are just going to put points at each value. So, and then we have just that line, and we have the closed circle. Okay, and then our next function is 80 from 6 to 15, 6 being an open circle. So at the value of 6, I'll use a different color here. You're going to be at 80 and with an open circle, and that's going to be all the way up until 15 with a closed circle. So we're going to go to 15, and we're going to put a closed circle there. And we'll attach those points. Okay, pause the video, try the last piece, and in a moment I'll just put up that answer as well. Okay, check your work. Hopefully your graph looks like my graph, and you're all set. Okay, this next part is evaluating the piecewise functions when you're not given a graph. We kind of did one of these yesterday, almost, but we're going to go more into it today. So it says evaluate the function for the given value of x. A is when f of negative 9. So really what that's asking is what is y when x is negative 9? The issue is we're given two different rules. We have this first piece, which is one rule, and then we have the second piece, which is another rule. So we have to ask ourselves, which rule should we be using to figure out the value of the value of y? So in order to do that, we have to look at the x value. So our x value is negative 9. We have to ask ourselves, which piece does negative 9 fit into? So we look over here and we say, well, is negative 9 greater than negative 3, or is negative 9 less than or equal to negative 3? Which piece does it fit into? Hopefully you know that negative 9 is less than or equal to negative 3, so that's actually going to use this piece. So I'm going to use the piece 2x minus 3. We're going to substitute in negative 9, and we get negative 21. So f of negative 9 equals negative 21. Okay, the next one. Next one is f of negative 3. So which piece does negative 3 fit into? Well, again, that's the second one because it's included. So I'm going to use the same rule, 2x minus 3. Substitute in the negative 3. And you should get negative 9, which means f of negative 3 is equal to negative 9. And one more, f of 1. So x equals 1. That fits into the top one because 1 is greater than negative 3. So we're going to use the rule 2/3 x plus 1 and sub in 2/3 times 1 plus 1. And we get f of 1 equals 1 and 2/3. You can write that as a fraction or a mixed number, whatever you want to do. I'm fine with. Okay, go ahead and try the you try problems. I'll put the answer key up in just a moment. Pause the video, obviously. Okay, the answer key for that is right here. So A is negative 3, B is negative 5, and C is negative 7. Okay? All right, number 7 is an extra. Know that there's an absolute value function and then a linear function. You're going to use your calculator for that. You can check the answer key that I'm going to put on Haiku for you. And then if you want a challenge, you do not need to know how to do this, but you know, some of us like to challenge ourselves, and I encourage you to. So please try number 8 and then check that answer on Haiku as well. You are more than welcome to email me. Please do. I look forward to your emails and answering them. If there's any other questions that you have, please let me know. And that is it for today. So have a great day. Hope you guys are doing well. I miss all of you. And that's about it. Have a good one.